Hello everybody and welcome to today's webinar. Thank you for waiting. Sorry there was a little bit of a delay. It's always quite difficult because quite a few people try and log in at the same time just as the session's about to start, so I wanted to give as many people as I can the opportunity to be here for the start of the session. Thank you again for joining us. We're going to get going now. I hope a few of you who did log in early had the chance to download this free ebook. It's an ebook on Tortoise SVN and the Subversion Cookbook. It's got some really good tips on using Subversion. There's a section at the end as well which talks about source control in Oracle. If you didn't get a chance, then you will be able to get this afterwards at redgate.com/oracle-svn-ebook. So just a few things, as always, before we start. Everybody in the audience will be on mute for the duration of the event. If at any time you can't hear me or Dominic, please do let us know via the questions or the chat box in your control panel. Of course, check your own audio settings and go to webinar settings first. Sometimes there are a few little sort of technical hitches with the sound. It's normally temporary, as you can imagine, with lots of people logging in and listening. Some things do happen. So if it cuts out briefly, it's probably just a temporary thing. Unfortunately, though, this session is being recorded. I will send everybody an email when the recording is available. If you've come to sessions before, you'll know that I do get these up quite quickly, so hopefully this should be up today or tomorrow. There will be a Q&A session at the end. We won't answer any questions until the end, but if you see things or if you want to ask, or sorry, if you think of things as the presentation goes along, please do ask the questions in advance in the Q&A set, in the questions panel. But again, we won't answer those questions until the end of the session. So this webinar is brought to you by Source Control for Oracle and Redgate Software. So the session is called Topics in Database Version Control, and the main presenter is Dominic Delmolino. As always, I'm James Mercer, so I'll put a picture up on the screen now, particularly for those of you who join me on a regular basis. As you know, I run these sessions twice a month. You might be interested to know where I'm broadcasting from. So in the background is the Redgate office. This was actually taken last October on our 13th anniversary, so you can see where I was sitting in this photo. And just in case you're unsure, that is everybody sat in a red T-shirt. We had to come in a red T-shirt for that day, and we sat in the shape of a red gate, although it doesn't quite look like that with the lens that we've used. So I'm part of the Oracle tools team at Redgate. I'm the creator of all things Oracle.com. In a moment, I will hand over to the main presenter, which is Dominic Delmolino, who's an Oracle ace, a member of the Oak Table Network, and he's Vice President of Data Architecture and Engineering at Agilex Technologies. For those of you who have never heard of Redgate before, so from that photo beforehand, obviously we've been around for 13 years. We've got over 600,000 professionals worldwide use Redgate software, including 93% of the Fortune 100 companies. There's some logos of the type of companies that use our products here. The thing that we really believe in and that we try and instill in all of our products is we design highly usable and reliable tools that solve complex problems in a simple way. And we're trying to solve the problems commonly faced by DBAs and developers. On the Oracle side of the business, we have 3 tools that make the deployment suite for Oracle. We have Schema Compare for Oracle, which enables you to compare schema structure and deploy changes between environments. Data Compare for Oracle does exactly the same for table data. And our new product is Source Control for Oracle. There's a screenshot on the screen at the moment of the Source Control for Oracle interface. I will be doing a demonstration, a quick demonstration, I might add, of this product after the main presentation, so please do hang around if you'd like to see Source Control for Oracle. As you can imagine, following the naming convention of the other 2 tools, this enables you to make, it helps you source control your schema objects. It's not a separate source control system. So this is the kind of tool that you need to easily check your database changes into Subversion or TFS. If you're having difficulty doing that, or you're looking for an easier way to do that, please do hang around for the demonstration after the main presentation. This webinar is part of a whole host of activities that I do to help support the community. This is something that Redgate really believes in. We've got loads of resources for all of the technologies that we're involved in, so SQL Server and .NET, and of course Oracle. So these webinars sit alongside all things oracle.com and free ebooks. You can find out about all of our Oracle educations at redgate.com/oracle-education. Okay, so I think that's enough about Redgate. Of course, if you want to find out more about us, just go to our website, redgate.com. If you're particularly interested, if you're specifically want to look at the Oracle stuff, which I guess you will, redgate.com/oracle. So I'm going to hand over now to Dominic Delmolino, who's going to drive the main presentation. Please bear with me just in case there are a couple of little technical hitches or a technical delay as I hand over control to Dominic.
Of the screen. Thank
okay,
you, James.
Dominic.
It looks like I've been given control of the screen, and you should see.
Absolutely, and that slight technical hitch was actually down to me, not the interface, and I left you on mute. So apologies for that, Dominic.
Sure. Can you see the my screen now?
Absolutely, yes.
Excellent. Okay. Well, I'll go ahead and get started then. And thank you all for taking time out of your day, wherever you are, to watch this presentation and webinar from Redgate on topics in database version control. I'm going to go through a variety of things here. A lot of this will be kind of conceptual discussion. I'll talk and show some examples of concepts and things that I've experienced over the years in attempting to do version control of database artifacts like schema structures and data. Go ahead and bring this through. So a little bit about myself. I've been working with the Oracle database technology stack since the early 90s, since 1990. I am a former member of Oracle Consulting's National System Performance Group. I was the CTO of a small company called Savant Corporation, where I learned a lot of good techniques about PL/SQL version control. And before coming to my current position at Agilex, I was the Director of Database Engineering at Network Solutions. I was in our engineering development organization and responsible for deploying the database infrastructure behind Network Solutions' consumer-facing website. So if you've gone and had to, in the early days where you bought a .com domain name from Network Solutions and gone to their main website, you're running PL/SQL code and interacting with an Oracle database that I was responsible for a group of people maintaining and writing code on. So if you're happy with the performance there, I'll take credit for it. If you're not happy with how it logs in and displays information, well, I haven't been there for a little while, so it may have changed. But basically, I wanted to point out the fact that it's something, an area of how to efficiently deploy database changes is something I've been interested in and focused on for many years. When I was at Network Solutions, it was important to be able to make changes to the main consumer-facing database in a way that did not require an outage, did not require a lot of time when we had to convert or transform legacy data or historical data to a new data structure. We didn't want to take hours of downtime to do that, though we had to find creative ways to introduce the database changes in a rapid and repeatable way so that it would not impact our ability to take in revenue for people buying domain names or other products from Network Solutions. So we were constantly working on ways to efficiently and reliably deploy database structure changes in a way that didn't require an outage. And I'm going to share some of the ideas that we've come up with from there, as well as talk about some of the current things I've been experimenting with and some of the state-of-the-art tools that are starting to come out that enable this. The first area that I find fascinating in database structural version control is the idea of whether or not it's important to maintain a copy of the database as it is today. So a structural model of the database as it is today versus the change log of changes that have been done to the database since it was originally created. And so you can think about two different models of what you're trying to control. You can say, we always want to just know how to rebuild the current database as it is today. Or do we want to know the history of, well, originally we had 5 tables, and then we introduced a 6th table, then a 7th table. And the way to build the database to its current state is to install the first version and apply all of those changes incrementally to get you to the current working state. And their various tools actually promote one process versus another. And so the sync model you'll see in some of the schema compare style tools. The directed application model you'll see in some of the change set based tools like Liquibase or Flyway are two open source models where you manage your change set scripts and apply them in order. And then those tools manage an understanding of whether or not a script has been deployed or not. And they can tell you, how have I built up the database over time. And so when thinking about how you want to do version control of the database, you may want to consider the ramifications of either model choice. Is it important to understand how you went from version 2 to version 3? Are there specific requirements of how the script changes or the structural changes are deployed? Do you have to account for data when deploying structural changes, and therefore it's important to understand the mechanism of going from one version to another? Or do you simply want to just validate and verify that you're consistently on the same version as you are in development or in QA? So it's an interesting dimension of how you would approach the problem. For the most part, change set application is a little more amenable to standard source code control processes, but that's getting different now and better now with some of the better tools and some of the ones you'll see from Redgate at the end of this as well. Another interesting topic in database structural version control is whether or not you have a central database in development that everybody works against, and then therefore as one reference development schema. Or do you have a model where every developer has a private version of the database that enables them with an ability to change things in parallel and not lock or block on someone else making a change? Do they have local copies of data? Do they have a local version of the database that then they can make changes to, and then those changes have to be synchronized and merged before being applied to what you would consider to be your integration database or a QA or pre-production database? And I've seen both of these as well, and there are hybrid models of this debate where you have a central database, but you give each developer their own private schema to work in, and that has some benefits and things as well. I'll talk about the different attributes of each of these models. And then now it's even more intriguing with the introduction of Oracle 12c, and where you have these pluggable databases. So you could have one central container database, and you might give each developer a private pluggable database. Is that another model by which you could kind of get the benefits of a centralized approach, but also give people that sandbox private space where they can do their own developments? Another area that I find fascinating in database version control is the notion of reference data management. A lot of people would like to think that reference data is similar in some ways to code, and so therefore it models some of the same problems. Do we have a sync idea of where this is the reference data, it must synchronize to that? Or do we want to track the history of what data elements were added to reference data, which ones were removed or retired from reference data? And so do we want to track the history of how we manage reference data as well? I'll admit to not having a lot of experience with data compare from Redgate, but I could see how that would be another tool in the arsenal of saying, how do I ensure that my reference data is up to date and synchronized and the same in all environments? And to me, the interesting aspect of that would be, how do I then instantiate that process of comparing and merging and making data the same into a source code control system, so I have the tracking and reference capabilities that are provided to me by a source code history. So I find that to be another interesting dimension of database version control, is not just the structure, but the reference data attributes and artifacts that you'd obviously want to carry along when building a new database from scratch. And then finally, the other area that I find interesting is the idea that you might maintain profiles of transactional data that can be loaded into a new database or a test database or a test environment to support certain kinds of activities, like different kinds of test data scenarios for QA process. You assume a customer has 4 products, 3 of which are in this form, 1 of which is coming up for renewal, and so are there test data cases that I want to create as code so I can reload them at any time? Are there test data profiles that show very large data volumes so I can do performance testing? And so do I have data sets that are not reference data but rather are test data sets that I want to check into source code control as well, so that I can, after creating a database, populating it with reference data, loading it up with a certain data profile that enables me to do repetitive tests in an objective way. So I can baseline and say, given this data volume, which has not changed, running new code against it, new SQL against it, it has certain kind of performance characteristics. So the idea that you might maintain data sets in different capacities in source code control as well is another area of interesting investigation, probably one that's least mature out of all the stuff I've talked about so far. The other thing I wanted to talk about, and I'll get further into the presentation, are some of the trends I'm seeing in source code management and continuous integration. The idea that we're moving, it appears, toward a more distributed development world where developers have their own environment that they work in, and they clone the production or clone the integration environment. So they're moving more towards something like Git as opposed to Subversion, where they clone and have a local repository, check things in, commit them, and then push to the central repository. I'm seeing more of that coming along with some of the developers I'm interacting with from a database perspective. And so how does the database source code control process match up with Git and Subversion? And I'll talk about that as well. Another fascinating idea is this idea of rollback, right? How do I, when I've deployed a database change, if it causes a problem or if it fails a test, how do I revert or back out that code? There are some tools that provide automatic generation of backout capability. I'll talk about some of that in that section on code reversion. There's also ideas, well, maybe we'll just flash the database back to prior to the deployment of the structural code. And how do I do that in a automated and reliable way? In the past, I've seen people do this manually. They have to write a backout script, and then your testing cycle gets severely elongated because you have to test deployment, test backout, and then test deployment again, right? Or test deployment, test backout, ensure that the backout puts you at a state that works. So there's a lot of different extra testing that goes on, and it gets more dicey the more you allow backout and reversion capabilities to be done manually. So if there's an automated way where you can objectively determine that you've generated backout code that is reliable, and if there's tooling to support that it is reliable, that's a neat feature of the ability to do source control. Because the real challenge is it's not like application building where you just say, oh, deploy the old version of the application. It's simple to swap it back in. Once you've deployed a change to the database, you can't just swap in the old copy of the database. Perhaps you can, but it's a little challenging to do that in an automated way. And then the last topic I'm seeing in continuous integration is this notion of test-driven development, such that you write your tests first, you then write code to make your tests pass. And can we apply the similar concepts to database structural design and development as well? So can I assert that a table will exist, have that assertion fail, I go to my database, I create the table, that assertion now passes, and I've gone through a notion of test-driven design and development for building tables in the database. And I'll talk about some concepts and ideas in TDD as well. So I want to get some more details on some of the topics I've introduced earlier. And this is the idea around having a central database that you wish to manage for version control versus distributed or private databases for version control. So obviously there are some pros and cons to each approach. I want to walk you through what I've learned in trying both approaches, and then we'll talk about how that applies to source code control and version control as well. So having a central database is nice because it's easy to share things, right? I can load my reference data once and everybody gets to see it. I get what I call immediate integration. This is where I joke with the continuous integration folks that You know, if something breaks, we all know it really fast because it's in one spot and everybody sees it. I also like the idea of a central database because your data folks, your development DBAs, can start to monitor the SQL that the developers are writing or using to interact with the database, and they may get insight to the poor SQL that's coming at the database early on. Now, there are ways around that. If you're able to establish a precedent that there is no SQL coming from the application, there's just stored procedures or how you get to the database, then you have better visibility into that. If all your SQL is encapsulated in stored procedures, you don't have this issue of random SQL coming in that you have to find out about that's poor and you have to tune. But in a central database, you get both of those things. If it's stored procedures, you'd see the SQL. If it's SQL coming in from the developers who are working against a central database, your DBA has visibility and can start to, hey, go over to Joe and say, why is your SQL so bad? Here's how you should tune it, that kind of thing. The cons on this, though, are the idea that a central database is prohibitive in terms of it locks things, right? If someone's working on something, we have to wait. And the developers say they don't like to wait. They want their own private copy they can work with. So the idea that there's some central shared resource is they think it has a bad smell to it. And so most developers will turn up their noses at this and say, why can't I have my copy of the database? Your central database prevents me from getting my stuff done because I have to wait on something being done, or I have to wait in line while someone else modifies that table. And so there's some overcoming there with some of the more modern developers. Potentially you have deferred source code management, because if you're doing everything in the central database, the idea that you have to get it into source code control is kind of an afterthought, right? Your primary goal is to do development, get the changes in so developers can work with it, and then SCM becomes something you think about when you're figuring out how to deploy the change to the next environment. And so it differs from distributed, where you're confronted with that ability to move code around more immediate, because everyone has to share what they've changed. In a central scenario, you potentially wait and don't think about SCM or version control or deployment options until later on in the process, which might have risks associated with it. And then, of course, there's the breakage issue. If I make a change to the central database and it breaks potentially everyone who's trying to work against it. Developers hate that because now you've essentially prevented them from continuing their work, and so you have this high degree of dependency and exposure when working with a central database that you may not have when distributed, which we'll talk about next. In the distributed model, of course, this is where every developer has their own database. Obviously, the nice thing about this is developers like this. You have a private sandbox for testing. Nobody locks them out. Another fascinating thing is they all have their own kind of same connection string. They connect. This is different from the central one. You might have the same connection string, but if you're doing private schemas, you wouldn't, right? Every username and password might be different for every developer. This one's nice because their configuration files all say, connect to this schema using localhost, and everybody has the same connection string that they're working with. The challenge, of course, with the distributed model is you need a really good process for capturing changes from each developer's workstation, checking them in and resolving conflicts and differences and merging them, and being able to share and then reapply those changes to everybody else who needs them. So you have this sharing challenge associated with that you need a really good source code management process around. The other challenge, of course, with the private databases is perhaps a lack of data. Right? You have probably the reference data is under source control, but at this point you may not have gotten to the point where you can deploy out large test data sets. And so developers write code or they write SQL, especially if they're writing using an ORM that just generates SQL, that isn't going to be fast or run well, or they may make decisions about SQL they think is fast on a very, very, very small database, a private personal Oracle instance, for example. And so there's a challenge there that you're deferring performance problems until late. And then also you get limited oversight and guidance capability. If you have really good DBA and data folks, they can't help someone if they can't see what they're working on. So in the distributed model, they don't see the potential problems of schema creation objects in SQL until it's been checked in and merged. And so you have this problem or risk area where poor code might get written and has to be adjusted or adapted when it's merged in the central location. Let's see if we can go to the next one here. Moving further along, I've seen the idea of having private schemas. This is nice, right? You have private sandboxes for every developer. There's no locking because everybody has their own schema. You have some oversight capability. You can see what everyone's doing as a DBA. You turn auditing on. You watch all the changes that are occurring. It's handy to be able to track and understand what the developers are all doing. The challenge here, of course, is every developer gets their own connection string, and they have to manage that. So they shouldn't be checking in configuration files with connection strings because you're all going to have a private connection string to check to work against. Again, you need the good CI and SCM approach because you have to merge the changes that every developer is making to their individual private schemas. You have the same problems around limited data, although in theory you can do things like store large amounts of data in one schema and point people at that, you know, through synonyms or views, but then their schemas aren't matching the actual real schema structure. So it's a challenge as well here. How do I make sure that everybody has access to a good amount of data to test with, and without making all these copies of it in the same database? You think that you should be able to share some of that. And then if you're doing associating branches or versions of your schema with a schema name, you're going to have some schema name proliferation challenges, right? As you give a schema to every developer and you have 100 developers, you now have a lot of schemas to manage and keep track of and understand who has what and which one is which. And having specialty schemas for purposes like testing and development and branching gets a little more challenging because you have to keep track of the differences there. The last one I want to mention is obviously something new is Oracle 12c, and that's the pluggable database concept. It's very intriguing, right? You can give someone a private database. Again, they have no locking. You have this oversight capability if you've got Uber privileges out of the as a container user, the ability to oversee all the private users and private databases. So there's some interesting abilities here with the pluggable databases. There are different connection strings for each developer, but at least now the schema names would be the same. So they can connect to the same schema, but they'll be connecting to a different database, SID perhaps, or database name, which makes their connection files, again, not something they can check in. They can check in the username, password perhaps, but not the connection string for which host or which database to connect to. Again, you need the good CI because you're going to be merging changes that are made in each pluggable database. And again, you have the data problem of ensuring that each version, each database that each developer is working with has data on this. I know there's a company in California called Delphix, D-E-L-P-H-I-X, that works on this ability to have clones of databases so that they're sharing the same amount of data but not having to actually copy it, which is intriguing. I know that they're working on figuring out ways to integrate that with source code control for the structural level as well. It's an interesting approach to having large amounts of data shared. Okay, so that was the longish discussion about whether you have a central database that you have to version control or distributed databases you have to version control, and some of the issues I've seen with both approaches. The next area I want to spend some time on is this idea of whether or not I just synchronize against a point-in-time snapshot, or I apply changes or change sets in a particular order to move a database from version 1 to version 2. And so the first approach that I think many of us have worked with, because we have tools like Schema Compare or Toad and SQL Developer, there are many tools for comparing schemas, is that, well, we'll just run a compare, we'll diff the schemas, and we'll just make them the same. We'll hit the button that says make them the same. And these are based on diffing, a reference model with the current model. Some of the ORM products do this as well. So Hibernate, for example, has an ability to verify that the database matches the object model that the Java developers have put forth, and that if it does not match, force the database to look like the object model by running DDL commands against the database to change it to look like the Java object model, which gives most of us DBAs, EBGBs, if that's something that's a normal process for Java developers. The good thing on the sync approach, though, is there's very good tooling around it. So you've worked with Schema Compare for Oracle, or source code control for Oracle, or even the Toad Compare kind of process. There's really good tools where you can investigate and look at, ignore storage, ignore schema names, and really do a nice job in comparing schemas. So it's easy to create or maintain kind of a reference physical data model by using this sync capability. The other nice thing I found with this syncing and tooling stuff is that you might do this after you've done your deployment. So one of the things we used to do at Network Solutions is we would do our deployment, and then the first thing I would do after deployment is run the schema compare type tool against what we've had in development to say, hey, did everything we think was supposed to go to integration actually make it? So did integration get deployed and everything's the same as it was in development? And no matter what process you're going to use for version control, I highly recommend more religious use of these kind of synchronization or comparison tools, and more, I don't want to say religious, but more strict interpretation or disallowing, I guess, of differences. Right? I've been places where problems come in because, oh, it's okay because the column order is different, or it's okay if the indexes are named differently, or it's okay if the storage elements are different. And what I found is when you get to production and there's a performance problem, someone says, oh, they used a hint with the index name in it, and that index name doesn't exist in production because it wasn't the same in development. Or the column order is breaking because someone used select star or did an insert without named columns. And so these kinds of things, if you want to avoid potential problems, you want to have very low diff counts, right? So even things that you might considerably ignore because they perhaps shouldn't make any difference, it's useful to have an attitude of, no, I'm not going to allow differences between production and earlier environments, on naming or whatever, storage layouts, anything that potentially could introduce some variability to how the production system runs, you ought to manage with some kind of comparison tool. Of course, the challenge with synchronization is the tool itself decides how to apply the changes. So column renames, data type changes, things where you have to potentially respect the data that's already existing in the table, you may want to have more control over, and the comparison tools may only have one way to do it. Right? They'll just rename the column. They won't create a new column with the new name and migrate the data and keep the old one there so the application doesn't freak out. And, there might be some things you want to do in how you decide to apply changes to your structural model that you'd like more control over. And some of the comparison tools don't have the ability to ignore or do a call out to a user-supplied change script. And so there's some real interesting challenges on how these tools generate scripts. I've been a big fan of having tools generate scripts at an object-by-object level, so I can perhaps replace one or introduce a change or orchestrate how they're applied. I like the idea, too, that perhaps you can apply the changes to the production database in parallel. So identifying dependency chains in the synchronization process so that I could say to the tool, run this against the production database, use 5 parallel workers, and that way, if I've got a lot of structural changes, I might be able to reduce the amount of time they are applied by understanding that they're independently applied to the database. And so an ability to identify dependency chains and apply the changes in parallel is something I'd like to see in some of these tools. And some of them just don't have rollback capability. They'll say the rollback capability is save a copy or a baseline of the production schema prior to the synchronization. After you've deployed, do their comparison back to that baseline and run the script backwards, if you will, to undeploy what was done. And so this gets also may make you nervous if you're not comfortable with your ability to save off the production schema prior to deploying and then comparing back to it and running the undeployment type script. So that can be a real challenge even with these synchronization tools. The other approach is what I call directed application. And this is where you write scripts or change sets that make the change. They basically alter statements, if you will. There are several tools for doing this. Liquibase is probably the most well-known open source one that is not as big in the Oracle community, but in the open source database community. Ruby, if you've been doing scripting with Ruby, has this concept of database migrations, which can migrate and change versions of the database. Or you can write your own refactoring scripts, which is generally what we did at Network Solutions. We wrote our own set of scripts that were checked into source code control to apply the changes and introduce the version to the database. The good thing about directed application is it's really good for tracking who made the change, when they did it, what the change is, when they did it, and perhaps why, if they comment that check-in of the change script. You have potentially more options for rollback because you're directing the exact action that's performed against the database. If you're using the Liquibase refactoring domain-specific language, the DSL that Liquibase uses to introduce changes. It will automatically generate a rollback script for some of those changes. So that's kind of neat. You have more control and orchestration ability over how the change is deployed. This gets back to the column renaming or data type change type activities, which are more challenging. And these tools are generally driven off of command lines and source code control, which means they're a little more amenable to continuous integration environments and tools like Jenkins or Hudson, who can make a call out to a command line to do this. It's one of the reasons I like Schema Compare for Oracle, in that it is a very full-featured and rich command line environment where you can direct Schema Compare for Oracle to performance activities using scripts or in a more headless mode, which is what a lot of continuous integration environments appreciate and would like to use. And then I guess the challenge, though, with this directed application approach is someone will come and ask you, well, where's the reference data model? Where's the reference physical model? It's a little harder to direct them from that because it really exists in the database as it is instantiated. It's not in source code control. And all you have in source code control is a list of scripts that were applied in order to get the database to a certain state. And so it's not as good for reinstantiation of a database because it has to rerun all of the Delta scripts. And for many people, the tools are limited or unfamiliar. Right? If you haven't worked with Liquibase or Ruby database migrations, you're trying to learn a whole new process for how to do database development that is amenable to source code control, and that can be really challenging and difficult as well. The rest of the slides I'm going to go through are a little less detailed. They're kind of more conceptual, so I hope we will get some time for questions and answers here at the end. I talked about some of the trends in source code management. My background's with SCCS and a lot of older tools where you check in and check out, hard checkouts of stuff. I've seen the rise of SVN, and unfortunately I was never able to really grasp SVN very well. But I have been a little more happy with Git and GitHub and Bitbucket, some of the other things that allow you to do kind of this distributed source code control management and distributed version control. They also are a little more, Git is more amenable to this concept of every developer has their own workspace because every developer has a local repository. And so I'm seeing a lot more movement toward Git or Mercurial for distributed version control overall in the industry. And it's not just in like the Java tools right now. We're even bringing, let me see, I can show you this. I've got a copy here of SQL Developer 4.0, which is now in early adopter status. You can go to Oracle OTN and download it. And you'll see now that they have this kind of ability to connect to Git and to Subversion. Right? And I know that RedGate's looking at adding Git to source code control for Oracle as well. And so it's kind of the area where I'm moving toward spending a lot of my research time is how do I get database version control compatible with Git, because that seems to be the source code control version that many of the CI people are moving toward. So I like that SQL Developer 4.0 now has that. I expect to start to see it in other tools like source code control for Oracle as well. Talked about reference data. I think we talked about this data like code that you manage is controlled via source code control management. I really would like it if some of the database documentation generators would generate reference data output as well, so you could indicate which tables you want to see the data for when you're producing database documentation. SQL Developer and Liquibase both have a nice ability to generate database documentation. I think I have it here. The older version I know definitely has it. Maybe I have to be connected to show that. But at least in 3.0 SQL Developer, when you're connected, you can right-click on a connection, and there'll be a generate there it is, generate database documentation for the schema, which is actually produces quite nice documentation that can be used to show people what your schema looks like. Let's see here. I talked a little bit about reversion or reverting database code and rolling back, and then I think more important to that is how do we ensure that what we've done is what we meant to do. So how do we test the application of DDL to a system prior to actually deploying it to ensure that it's adhering to some of the standards or practices or what we meant to do. So this gets back a little bit to TDD, which I'll talk about in a moment, but it does mean how do I kind of pre-test code so that I don't have to deploy it and then figure out how to back it out. Is there a way I can run tests on my DDL prior to deploying it so that I can feel more confident about the fact that I won't have to back it back out. So one area I like about this is the idea of test-driven development. Can DDL, can database changes be test-driven development? Can I do rule assertions in the database so that when I attempt to create a table, it fails a rule and therefore doesn't get created? Or when I create it, I run my tests against it and it tells me that it doesn't adhere to a rule that I want, a test that I wanted to have to ensure that it's done correctly. And so can I do things like in SQL Developer Data Modeler, you can see these rules, right? Identify tables without columns or identify tables with wrong naming standards. Can I do this in the database so that when I actually attempt to create a table, I get warnings that it's not following a naming standard that I want to establish, and or before I even created it, rejects it because it doesn't follow the standards. To me, these are things that if I can get them into the database, if I can do TDD early on, I can do things that enhance the quality of the database when building it. So I'll find this out later. We've been doing things like branching, where we add a suffix to a schema name and then use that as a way to test changes. And so this is really nice when you're looking at some of the schema compare tools, right? If I have a schema that's kind of my sandbox schema that I make changes to, I run my tests against it, it's green, I can then compare it to my schema I want to then share with the world and create the deployment necessary to share it with someone else. So it'd be nice to have this kind of local schema and then another schema in the database that's your development schema, that's the one that will be shared out to the world and source code control checked. So this idea of having multiple copies of the schema for different purposes, I think, is an important one. Do I have one for local testing and changes? Do I have a reference one? Do I have one that was generated out of the ERD modeling so that I can check against that if I need to? So I like this idea of having multiple copies of a schema with some kind of purpose associated with them in the same database so I can do the comparisons and test deployments locally. One other area, and there was a really good Redgate presentation on this early on, James could probably refer to it about a month ago, on integrating database deployments with Jenkins. Fascinating presentation. If you haven't seen it, I recommend taking the time to do so. And how do I use a build tool to automatically deploy these changes in a way that supports the CI process of it's a successful build or a failed build. It has a temporary workspace that it works against to test the build. And then further, can I do things like generate during the build process the JPA class files for Java programs? Can I automatically generate a naming standard for the object attributes using camel case off the column names? You know, they're fascinating things you can do to automate some of the things you need to do in database development so that you can reduce the error-prone manual processes that many people do there. So I think with that, I've got about 11:50 my time, Eastern United States, so I think we've got about 10 to 15 minutes for questions, and then I know time for the demonstration at the end that you want to do, James, as well. So at this point, I'll open it up for questions if there's been some that anybody typed in or want to ask right now.
Thank you, Dominic. So I think what I'll do, I'll take the screen back. So whilst we wait for questions to come in, so please do ask some questions. This is obviously a great opportunity if you want to ask Dominic about kind of areas that you're thinking about in terms of source control and continuous integration. And what I'll do, I'll just actually bring up the section of our website where you will be able to find out a bit more information. So if you go into the webinar section, so where you would have registered for this particular webinar, if you go back there, you'll see that there is a webinar on continuous integration with Jenkins and Redgate tools, but we also have a dedicated section to continuous integration, which is redgate.com/oracle-ci. So there's resources there, including kind of a walkthrough of how to set it up with TeamCity or Jenkins. We've got some screenshots for TeamCity here, but we've put some little notes there on what the differences are between TeamCity and Jenkins. The important thing is that kind of all of the command line hooks that if you obviously would need to install Schema Compare for Oracle, the command line interface, and then all of the command line hooks are here. So we talk you through that. So please do check that out. So Dominic, we don't have any questions from the audience.
Okay. Well, clearly that we have the material available, and if there are questions, I'm sure they can feed them back through you. Or is the webinar link available through All Things Oracle?
Absolutely, and so that would be probably the easiest place to ask questions afterwards. So if you do go to allthingsoracle.com, I will share this in the email as well. Under the webinars tab, you'll be able to find this particular webinar, and then there's a kind of a comment section, as you can imagine, with these type of sites, and any further questions you can ask there.
And then James, did you want to show the source code for Oracle demonstration as well, or?
Yep, absolutely. So before I go on to the demonstration of source control for Oracle, I just wanted to remind you of a couple of upcoming sessions. So there's a session next week, which is being presented by Karen Millsap on performance is a feature. Here is the specification, and there's the webinar following that is by Morton Egan on hacking the Oracle Cloud. It's not quite as harsh as it sounds. It's actually how to get the most out of the Oracle Cloud. If you're interested in Oracle Cloud, I'd recommend you registering for that session at redgate.com/Oracle webinars. So I'm going to move on to a demonstration of source control for Oracle. This is the Redgate product. Before I do that, I would just like to thank you all for joining us for the main presentation, and of course thank you, Dominic, so much for presenting the topic. It was very interesting, and I think there's a lot of sort of points there and take homes for people that, particularly if you're considering working in a distributed or a sandbox environment, and the things that you need to be aware of.
My pleasure, James.
Okay, so if you're hanging around for the demonstration of source control for Oracle, it will be a quick demonstration, so a sort of a 5 to 10 minute overview. Please do hang on the line, and if you could just give me 30 seconds or so just to bring my remote desktop across and to drive the demonstration. Okay, I'm all ready now, so thank you for hanging on the line. So I want to go through a quick overview of source control for Oracle. I've got a quote up on the screen here, because this is something that we really believe in ensuring with our tools. This is a quote from Lewis Cunningham, who's a database architect, Oracle Ace director, who's had a look at source control for Oracle, and the thing that he's really hit on here is it's a huge time saver for the teams that he works with. Before I go on to the demonstration, I wanted to give a quick overview of where source control for Oracle fits into your process. So where is source control for Oracle saving time? Where is it making it easier for you to source control schema objects? Dominic spoke a bit about distributed environments, and through this demonstration I'm going to show you two scenarios. The first scenario I'm going to show you is a team working on a shared development database. So we've got a quick diagram here. So as you can imagine, all the team members are making changes to the same development database. Once they've made those changes, they want to put them into source control. Obviously, it enables them to track the changes, it keeps a history of the changes, and importantly, it enables them to quickly revert anything that went wrong. So source control for Oracle sits between the database and SVN or TFS, and it enables you to check changes in and also to pull changes back out of Subversion. In terms of actually then pushing those changes from development into test, Dominic mentioned Schema Compare for Oracle. That's another tool in the deployment suite for Oracle, and that's the product that you would use to then move those changes once you're happy with all the work that you've done and you're ready now to put those changes into test. The important thing is that you're taking those changes from your source control repository and you're taking those changes then into test. So that's the first scenario that I'm going to show in the demonstration. Okay, so I've got source control for Oracle open here. As you can see, it's a very clean looking interface. It is a Windows application. It's not a web application, although it does look a little bit like a web application, but that's just down to the Windows 8 or the Metro design. And I've got a project set up here, and what a source control project is, it's just that we've got a database here, which is the obstacle database. I've got a schema called Widget James, and I've mapped that to my source control repository. You can see the URL here. Currently, everything's up to date. That means that the database is in sync with the source control repository. So what happened if I was to go into SQL Developer and I was to make some changes? For the purposes of this demonstration, I'm cheating. I've got a script here that's going to do all of the hard work for me. So I'm going to make changes to the database. So I just want to scroll the screen up a little bit. What you should be able to see on my taskbar is the source control for Oracle icons. An icon has now got a little star. The reason it's got a star is because source control for Oracle has recognized that the changes have been made to the database, so that the database is now out of sync with the source control repository. So let's click on that and we can jump straight into that particular project. So the script that I ran made these changes. So it's made a couple of edits. So it's edited a table, it's edited a package there, and it's created a number of new objects as well. So a table, a trigger, and a sequence. And this is where source control for Oracle really comes into its own, because having made those changes and source control for Oracle has picked those changes up, to check these changes into source control is as simple as typing a message. So I was always told not to kind of type comments in during a live demonstration, because obviously you'd want to put something more useful, but for the purposes of this I've just put a quick message there. You'd obviously want to describe accurately what's happened. You could use the side-by-side diff view to see what these changes actually are, and you can see that the changes are all highlighted. The left-hand side is the database object, and that's the equivalent object in source control. This is where the differences lie. You can check in groups of changes together, or you can check in individual changes. If there are objects which are dependent on other objects, you're going to get a warning as well. So it does handle all of this stuff intelligently, and you can select all of the objects together that are dependent on each other to ensure that things aren't broken. For the purpose of this, I'm going to select all of the objects. I type my message in already. I click check in. And you can see how quick it was. I know we're only talking about a few objects, they're reasonably small objects as well, but it's very quick in terms of actually converting those objects into files and then putting those files under source control. We can click on the history tab as well, so we can see the changes that I've just checked in, and we can go back and look at all of the changes object by object. Again, we've got this lovely side-by-side difference view. You can see it's got some information here which it's taken from source control. So it's got my username, it's got the changes and the comments. Remember, we're working in a shared development environment. So there are other colleagues on my team as well who are also checking in changes. And we can see here, we've got one of my colleagues, Michael Christofides, he's checked in a change, so I can see which changes he's checked in as well. So this gives you some nice visibility to what's happened in Subversion. Okay, now we're back to the right screen. Apologies for that. But source control for Oracle has a number of, or has one particular feature. If you're working in a sandbox development environment, now this could be that each developer has a local copy of the database. I guess that's very unlikely due to sort of the overhead and the cost involved with that. But it could be that each developer is working on a private schema, their own schema within a shared development environment. In this scenario, source control for Oracle, each member of the development team would have a copy of source control for Oracle. And they would be able to check changes in and then get the latest changes out of source control, so that the changes that their colleagues have checked in. Again, source control for Oracle sits on this side, so it's enabling you to check your changes into Subversion. When it's time to deploy these changes from development into test, again, you'd use Schema Compare for Oracle to take the changes out of Subversion and then deploy them into test, and again, going forward from test into UAT to production, etc. Okay, so I'm just going to go back into SQL Developer. Just want to open up the file tree here. I'm just going to scroll down to this schema here, which is called Widget Michael. As you can see, Widget Michael is completely empty, so there's no objects in the tables or in the views or anything like that. Sorry. What I want to show at this part of the environment, I'm going to show you how to set up a distributed scenario within source control for Oracle. But importantly, we've got, if you can imagine, we've got a new member of the team. So Michael's just joined the development team. He's working on his own schema. I'm obviously working on the Widget James schema, and we're going to populate this schema with the latest changes. Importantly, we're going to populate those changes out of source control. But this will also give you an idea that as another member of the team makes changes to their schema, then Michael will be able to get those changes. He can also then make his own changes and check those changes in. So to do this, we need to set up a new project. This will give you a good idea of how easy it is to actually connect your database to source control in the first place. I'm going to be connecting to SVN. I'm going to be using the same database that I was using before, which is the optical database. This time I'm going to be logging in as Michael. I'm going to be connected to the same source control repository. I'm using Subversion. I could be using Team Foundation Server as well. Let's find this widget Michael schema. I'm going to map this to the same folder that I was using under the James project. And I'm just going to call this project widget Michael. It actually doesn't matter what you call the project. This is for your own reference. But again, we've got a nice little summary here. So optical database. This time it's the widget Michael schema, and again it's mapped to the widget folder. At this point, I can add other schemas to this project if I wanted to. And I'm going to create the project. So the first thing that's going to happen is Source Control for Oracle is going to see where the differences are between the schema, widget Michael schema, and the source control repository. As we just saw in SQL Developer, that schema is completely empty. So the message we've got here is that there are 15 changes to get. And this is the tab that's that's different. We were looking at the check-in tab before. We're now looking at the get latest tab. And these are all of the objects. So I obviously checked in some objects beforehand, and I checked in a few changes in the demonstration earlier. There's nothing in Michael's schema, so the left-hand side of the screen is empty, but again, we can look down the side-by-side diff view and just check the script and ensure that we do want to apply the selected changes to the database. So this time when I click on this button, what's going to happen is Source Control for Oracle is going to convert those files back into database objects and then put them into the schema in the correct folders. Okay, so that's happened. Let's go back into SQL Developer. Let's just refresh this so you can refresh all of those, and as we can see now, we've got all of the objects that we've just seen or we've just reviewed in Source Control for Oracle. Of course, as we make more changes, so let's make a couple more changes, Source Control for Oracle is going to pick those changes up. This time that script meant that I made some changes. Remember, I was using the widget website. So again, I can review those changes. This time we're dropping a table and we're editing a package. Of course, again, I can look side by side at the view. Let's check those in exactly the same way. The great thing is that if we refresh Michael's project, the two changes that I just checked in, Source Control for Oracle is going to say these are two changes, these are two differences, two different objects in the source control repository that are out of sync with your schema. So once again, we can apply those selected changes after we've reviewed them. We can apply those selected changes to the database. So I hope that gave you a quick overview of Source Control for Oracle by Redgate. Just as a quick summary, the Source Control for Oracle enables easy database source control currently with Subversion and Team Foundation Server. It makes it easy for you to check your changes in, and if you're working in a distributed environment, it enables team members to share those changes easily. Of course, it does keep a record of changes for you as well. So it gets over some of the difficulties, and obviously enables you to remove some of the manual processes you might have in place to try and do this, particularly actually converting the objects into scripts and then putting them into source control. It's a standalone application, so all of your team, you can carry on using your SQL editor of choice. Some of the team are using SQL Developer, some are using Toad, some are using Peel SQL Developer, etc. It doesn't matter. Source Control for Oracle, remember, is working between the database and the Subversion or the source control repository. If you're looking for an easy way to set up sandbox development environments, then this tool will certainly help. The important thing is, though, by using this product, it enables you to set up these environments from your source control repository. So you're confident that you're working, I guess, if you're using your source control as the source of truth, that you're working with the latest version of the database. It's an integral part of the deployment suite for Oracle. I did highlight in the diagrams where another tool fits in, which is Schema Compare for Oracle. So you use Schema Compare for Oracle to deploy the changes out of source control through to your testing, and then from testing to UAT, etc. As with all of our tools, you can download a fully functional free 28-day trial at redgate.com. To download source control for Oracle, go to redgate.com/source-control-for-Oracle, or just go to redgate.com/Oracle, and you'll be able to find the tool easily there. So thank you very much for hanging around. I would be happy to answer any questions that you may have and go back over the tool if you'd like me to. Okay, thank you. I've got a few questions in here, so let me start from the top. A general question: yes, this will be part of the recording that you'll get for the whole webinar. I will send you a link in the email for more information, and there is actually a shorter video. So this particular question was in terms of sharing it with other members of your team. We would be very happy to do a demonstration to teams within companies if you'd like that as well. When you get the email from me, if you're interested in a demonstration or you'd like more information, please just reply to me and I can provide that for you. So a question here, thank you. How about just adding a column to a table? So the example that I showed there was we deleted a column from a table. Either way, source control for Oracle is going to pick that up as an edit. So if a member of your team added a column, then you'll be able to check that change into source control. Very good question here about merging. So currently, we don't handle merging in an intelligent way at all. We don't really handle it. In the example of the sandboxed environment, if two members of the team were to try and change the same object at the same time, it would show up as a conflict. The option you have then is to decide whether you want to take the version in source control or the version in the database. That's certainly something that we are working on. In terms of pricing, there is pricing available on our website. We're very transparent about pricing. It will be dependent on where you are in the world, so we do localize our pricing. If I go to source control for Oracle webpage and click on the pricing button. Then you will see details for the product here. I'm based in the UK, so this is obviously showing the UK price. So a question here, no, does the tool itself create any database objects? The tool doesn't, so if you remember from the diagram, source control for Oracle is working between the database and Subversion or your source control repository. It would, so it won't create objects. I guess what you're talking about there is to just use it to set up a database from scratch. If you do already have a shell of a schema on your database, then you can use it to take objects that are in source control that have been converted into files. You can then convert them into objects and populate the database as I showed it in the last example. Is it possible to customize the script that the tool generates? It isn't, and that actually, we have had some feedback that it'd be good to sort of look at that script. But if you're interested, I guess you'd be sort of interested in terms of of customizing the script when you're looking to deploy from source control into testing or etc. With Schema Compare for Oracle, you can review the script and you can export the script, customize it, and then run it through your IDE. So again, source control for Oracle, really what the benefit is making it easy to check your changes from the database into Subversion. So you're making the changes in the IDE. When you're ready to check them in after you reviewed them, then that's where source control for Oracle fits in. Unfortunately, source control for Oracle doesn't yet have a command line interface. That will be something that we're working on. As Dominic mentioned, Schema Compare for Oracle does. And there's information on the Schema Compare for Oracle page, but the command line interface is very rich. I mean, you can carry out comparison and deployment tasks from database to database and from obviously script folders, so from Subversion into a database using the command line. A good question here. Maximum number of database objects that can be comfortably handled. Lots. I don't actually know a figure for the exact number. We've done some great testing. We had a good beta program running during the development of the product, and that really helped us. We thought we'd done some good testing in-house with pretty large schemas. One of our customers pointed out some improvements that we had to make due to an extremely large database with lots of schemas, lots of objects in there, and we did handle that quite comfortably. Unfortunately, I don't know exact figure. There is a trial. Please do try it out. Try it out on your larger schemas. It would be great to get your feedback on how it works. In terms of data, source control for Oracle doesn't yet handle table data. That is a feature that we have in our equivalent SQL Server product, and that's something that we'll certainly be looking into for source control for Oracle. But currently, source control for Oracle just handles schema structure, schema objects. And actually, whilst we're on the topic of enhancements and improvements that we could do to the product, at the bottom of the source control for Oracle page, we have a link here to our user voice page. And you can see that the second one, second most kind of requested, or I guess voted, is to do with data. The top one is about source control for Git, but please do go to our user voice page. Once again, you can just find that at the bottom of the source control for Oracle page on the Redgate website. Click on this button here. Please add your suggestions. Have a look through the other suggestions that we've got here. Vote them up. Add comments to them. This is a version 1 product, and we really need your help in adding new features, improving it, and developing the product that will become most useful for you. A question here in terms of something I sort of mentioned earlier about the source of truth. So we certainly recommend that source control for Oracle, you use that as your source of truth. Ideally, as developers on the team are making changes, they should be checking those changes into source control. this not only enables you to keep a record of all the changes, in terms of actually keeping a record as well, the really important thing here, it gives you some insight as you're adding comments to the check-in, which is, I guess, where my demonstration fell down a little bit, because I didn't put a particularly useful message. But it's one thing having a history, it's another thing having accurate comments so that you can understand exactly why certain objects were changed and why a development took a particular path. Of course, if everybody's checking changes into source control as they're making changes as they should be, then the source control repository should be the version that you would then deploy from through to test. A couple more questions in here again about is the webinar being recorded? Yes, like all of the Redgate webinars, this is being recorded and you will be able to access this afterwards. Okay, so there are no more questions. Thank you very much for hanging around for the demonstration, and thank you so much for putting questions in. I've just left the Redgate website up on the screen here. If you go to redgate.com/Oracle, this is where you'll go, and you can see that there are quick links to the 3 tools that make up the deployment suite for Oracle. You can find out more information from here, and again, you can download a 28-day trial. I'd recommend doing that. You might as well give it a go in your environment, see what happens, and once again, please do share your feedback with us. So I'd just like to finish off once again, thanking you all for joining us for the main presentation. Thank you for staying on the line for the demonstration of source control for Oracle. I wish you all a lovely day or evening, depending on where you are in the world. I look forward to you joining me at the next webinar, which is next week on the 31st. Thank you once again.